Okay, let's start. Let's start. Write down today new topic. Write down today new topic. Inequalities. Inequalities. Okay, write it. Inequalities. Okay. Now inequality is very important lesson. Inequality is very important lesson. So definitely for your A-level examination there will be part A question for pure mathematics. 2.5 marks surely will be there. That belongs to modulus inequality part. And further, when we are doing questions, there can be some inequality analysis. Then this is very important session. So we have to analyze polynomial type inequalities. In all levels, you have done few things, linear inequality type. But we have to further analyze about quadratic inequalities, cubic inequalities, likewise all polynomial inequality types. All polynomial inequality types we have to analyze. And further we have to analyze rational type of inequalities. Rational type of inequalities. We have rational function, likewise we have rational inequalities. And further we have a special function called modulus. Then modulus functions, with that we have modulus inequalities. Then definitely for your A-level examination there will be modulus inequality question. Okay, so I'm going to complete this lesson as soon as possible. Okay, now here the basic concept. You consider two real numbers AB. Consider two real numbers AB. So here when you consider A minus B, so we have three possible results. We have three possible results for A minus B. So one result that can be positive value. Another result that can be 0, that can be negative value, no? Negative value. So if the result is positive, A minus B positive mean we say A is greater than B, no? When the value is 0, we say A equal to B. And when A minus B negative, we say A less than B. A less than B. Then we have only three conditions. With two real numbers, we have three conditions. A greater than B, A equal B, A less than B. No any other thing. That is the basic concept of inequality. Okay, then further we have, when you consider positive value combination with product, then the result is positive. Then negative product is positive. Then positive into negative product is negative. No? Then positive plus positive, the result is positive. Then negative plus negative, the result is negative. But positive plus negative or positive minus negative, here we can't say the sign, no? Can't say sign. So these are fundamental rules, no? Fundamental theorems. So with these theorems, we can derive many other inequality rules and theorems. Okay? Then we have to analyze those things under this inequality lesson. So I told you there are different function types. There are some function types like polynomial functions, rational functions, irrational functions, modulus functions, logarithmic functions. Likewise, there are many types of functions. No? So with those functions, there can be inequalities. There can be inequalities like polynomial inequality, rational inequality, modulus inequality, irrational inequality, can be logarithmic inequality. But we mainly focus on polynomial, rational and modulus inequalities only. We mainly focus on polynomial, rational and modulus inequalities only. But there can be many other types. Okay. Now, when you consider equality, we have equal sign. So when we consider equality, we have few solutions. We call finite solutions. We have finite solutions. There can be 1, 2, 3 solutions. Likewise, we can count. But for inequalities, there are infinite solutions can be there. Infinite solutions. Then we have to represent those solutions as a set. So we get solution set. Not only one solution, but there can be many solutions. Okay, using sets we can represent it. Okay, that is inequality. Okay, just write down. Let okay, write down let simple a and b are two real values. Let simple a and b are two real values. Simple a and b are two real values. Then a minus b has three possibilities. A minus b has three possibilities. A minus b has three possibilities. Within bracket, positive, 0 or negative. Positive, 0 or negative. Close the bracket and further write. For these possibilities, the relation between a and b can be written as the given below. Okay, you just write only this part. Okay, so under all levels you have analyzed linear type inequalities, you know rules. Okay, further we have to think more than that. Okay, now just write. Consider the following combinations of positive and negative values. Consider the following combinations of positive and negative values. Consider the following combinations of positive and negative values. Okay, just write all. Okay. Now further you write, by considering the above combinations, by considering the above combinations, by considering the above combinations, theorems on inequalities can be obtained. Theorems on inequalities can be obtained. Okay. Now here we have to analyze few theorems on inequalities. Okay, we have proof. You need to remember them because sometimes for first term test there can be theorem proofs. But other than that, for A levels and all, we don't have any proof. We have directly apply these theorems. Okay, here it is. First one. Let A, B, C real values and A greater than, first one, A greater than B and B greater than C. Then A greater than C. Second one, A less than B and B less than C, then A less than C. Okay, this is one thing. Okay. Then we have two inequalities, no? We have two inequalities. We have gathered it together. Now here the proof. So here given data, A greater than B, no? So that means we know A minus B positive, no? Positive. Then another one, B greater than C given. B greater than C given. Then B minus C positive. Then you add these two, here 1 and 2. 1 plus 2, the result A minus B plus B minus C, positive, positive addition, positive. Then A minus C positive, no? Then A minus C positive mean A greater than C, no? A greater than C. That's how we prove. Then here, using previous rules, we can derive that theorem. Then we can gather two inequalities together. Here there's common term B. Okay, similar way you can prove this one. See, A less than B mean A minus B negative. Then B less than C mean B minus C negative. Then add them here 1, 2, 1 plus 2, A minus B plus B minus C, negative plus negative, negative, cancel B, A minus C negative, that means A less than C, no? That's how we prove first theorem. Okay, just write first theorem. and write proof. Do it soon. Okay, that is very simple theorem. So here same thing, A greater than B greater than C. Here this is double inequality now. Then you can remove this part and you can move A greater than C. Now A less than B less than C case, here we have double inequality. You can remove middle one. Then finally A less than C. Likewise we can directly write. This is double inequality combination. Okay, not that one, double inequality. Double inequality combination, just note it. Okay. Now let's say another theorem. Let's say another one. Okay, say this. Let A, B, C real values, A greater than B and A greater than B. So then A plus first one, A plus C greater than B plus C. Second one, A minus C greater than B minus C. That means we have inequality here. We can add any value for that inequality, both left and right hand sides. We can add value without changing its sign. And similarly, we can subtract any value without changing the sign. Okay, here it is. So without changing sign, we can add or subtract. See proof? So here given data, A greater than B, no? So the idea is A minus B positive, no? That is fundamental thing. Now you do this, say, A, you add C value and add C value for this, then no effect here, no? We can cancel C, no effect there. Therefore, the sign won't change, positive. Sign won't change. Then we know here difference positive mean here this one greater than this one, no? Therefore, say A plus C greater than B plus C. Then second proof, A greater than B, the idea A minus B is positive. Then you do similar thing, A plus C minus B plus C. So we can cancel C, no? Then no effect here. So the result is positive. Then for this case we know, subtract. Subtract. Then we can cancel C, no effect. Therefore, A minus C greater than B minus C. That's how we prove. Then you remember, we can add any real value for any inequality, both left hand and right hand sides. We can subtract any real value by the inequality, both left hand and right hand side. Okay. Okay. Write it. Okay. With star mark write down. With star mark write down. With star mark write down. For an inequality, for an inequality, any real value can be added or subtracted. Any real value can be added or subtracted without changing the sign. Without changing the sign. Any real value can be added or subtracted without changing the sign. Okay. That is for addition and subtraction, but for multiplication and division, that is somewhat different. Okay. Now see third one. Let A, B, C real numbers and A greater than B and C greater than 0. C greater than 0. Take this case. Then first one AC, BC, then A into C, B into C, sign won't change. Since C is positive value, this inequality sign won't change. So when you divide by that positive value, this sign won't change. D less than 0. A, B, C, D real values, A greater than B, C greater than 0, D less than 0. Then D value negative. So if you multiply by D now, AD, BD, you have to reverse this sign. So when you multiply or divide by negative value, you have to reverse the sign. That is very important. Here third one, fourth one. Then when you divide A over D, B over D, then you have to change this sign. That is very important thing. Very important thing. Okay. See this proof. So here given data, A greater than B, no? Then the idea is A minus B positive. Then C greater than 0 mean C positive, no? Then A minus B times C. Positive into positive, we know it is positive. Then AC minus BC, positive mean AC greater than BC, no? AC greater than BC. Okay. Then second one, here A minus B divided by C. Positive over positive, we get positive value. Then A over C minus B over C, result positive. Then A over C greater than B over C, no? Okay. Then you can divide or multiply any inequality by positive value without changing the sign. So when you multiply by negative value, we have to reverse the sign, no? Okay. Then we can do this proof as well. Then A greater than B idea, A minus B positive, D less than 0 idea, D negative, then AB times D, A minus B times D, positive into negative, negative, then AD minus BD, negative, then AD less than BD. Okay. Here first one, here second one, here third one. We can do similar thing for fourth, no? Then A minus B divide by D. Then here positive divide by negative, we get negative results. A over D minus B over D. Negative, then you can say A over D less than B over D, no? That is very important thing. Okay. Then when you multiply or divide by negative value, no need to change the sign. But when you multiply or divide by negative sign, then we have to reverse the sign, no? Okay. Write and do that proof. Here this theorem proof only important for first, second terms only. Yeah? Other than we don't get these proofs. Okay, but here we have to apply these all theorems directly when we are evaluating some inequalities. Okay, somewhere here just write down with star mark. With star mark write down. An inequality can be multiplied by or divided by, can be multiplied or divided by a positive value without changing the sign. But when an inequality is multiplied or divided by a negative value, the sign get reversed. Next star mark. Therefore, any inequality cannot be multiplied or divided by an unknown quantity. Okay, that is very important. Huh? You can't multiply or divide by unknown quantity. But we can add positive value, we can subtract positive value or negative value, or we can add any unknown quantity for inequality. But multiplication impossible. Okay, that is very important thing. Okay, that is rule number 3. Okay. Now let's move a little further. Fourth one. Consider AB real values, positive real values. This is very important, positive real values, and A greater than B. So we have inequality here. We know both sides positive. A, B positive real values. Both sides real, positive. Then we can power this. Then A to the power 2, B to the power 2. No need to change this sign. A to the power 3, B to the power 3. No need to change the sign. Third, A to the power 4, B to the power 4. Without changing, we can power it. We can take any power. So let's say general one, A to the power n, B to the power n. N positive integer. Okay. Then positive integer powers 1, 2, 3, 4, 5, 6. Likewise positive integer powers. But if you get negative integer powers like 1 over A, 1 over B. So negative integer powers, we have to reverse this sign. Reverse the sign. Okay. So here another way, A to the power minus 1, B to the power minus 1. So we have to reverse the sign. Then A to the power minus 2, B to the power minus 2. Here this sign we have to reverse. A to the power minus 3, B to the power minus 3. We have to reverse the sign. Likewise, a to the power minus n, b to the power minus n, we have to reverse the sign. That is very important thing. Okay, then we can power it. Then positive integral powers without change in the sign we can do. But for negative integral powers, we have to reverse the sign. Okay. Okay, just write it, then we can prove it. Just write it. Here 1 over A, 1 over B, just like cross multiplication. Okay, let's try to prove them one by one. Okay, now you better do with me. So one data, here A greater than B. No? That means A minus B positive, no? Positive. Then think about A square minus B square. First one. Think about A square minus B square. Then here factors A minus B, A plus B. We know A, B positive real numbers, no? Then definitely positive addition is positive. Since A greater than B, A minus B positive, then full result is positive, no? That means A square greater than B square. Likewise, you can prove. Then think about A cube minus B cube. Here difference of two cubes. Factorize A minus B, A square plus AB plus B square. Here difference of two cubes. And we know AB positive real numbers, then positive real number addition positive. Then since A greater than B, A minus B positive, then here positive. Then we can say exactly full relation is positive. Then you say A cube greater than B cube. Likewise, we can easily prove them. Okay. Now let's move to third one. A to the power 4 minus B to the power 4. Here we can factorize A square minus B square, A square plus B square. Further we can factor A minus B, A plus B, A square plus B square. We know positive number addition positive. Since A greater than B, A minus B positive. Then full relation positive. So that positive means A to the power 4 greater than B to the power 4, no? Okay. Do that proofs. Okay, then let's see for a to the power n minus b to the power a to the power n greater than b to the power n proof. Check this now. You think about a to the power n minus b to the power n. Then here for this we can write factors a minus b. So under foundation course we have done that factorization thing. No? Then a minus b, there will be factor a minus b. Then you have to start with a to the power n minus 1 plus a to the power n minus 2b plus a to the power n minus 3b square, so on we can write. A power decreasing, b power increasing, final term will be b to the power n minus 1. So within any two terms positive. Then we know all a, b terms positive, addition there, therefore definitely here positive. And we know again a minus b positive, then no worries, everything positive, that means positive. So the idea is a to the power n greater than b to the power n. Likewise we can prove. Okay, do that as well. Okay, now let's see for negative indices. Check it now. I'll go for this. So given a greater than b, no, then the idea a minus b positive. A, b positive real numbers. So this thing can be right for positive integers only, not for all integers. Okay, now first case, think about 1 over a minus 1 over b. So when you simplify this, get common denominator a, b minus a. Then a minus b positive mean b minus a negative, no? Then here negative, ab positive. And negative over positive mean negative value. So that means 1 over a minus 1 over b less than 0. Then 1 over a less than 1 over b. 1 over b. Okay. Then by this you can say a greater than b, then the order is a, b positive real number. Then when you get reciprocal 1 over a, 1 over b, you have to reverse the sign. So see, 4 greater than 3, then both sides positive, then 1 over 4, 1 over 3, you have to reverse the sign. Okay, likewise you can do 1 over 4, 1 over 3. Okay. Okay, do this proof and note this. Okay, now you better do with me. Let's move to these three cases. Consider 1 over a squared. Consider a to the power minus 2 minus b to the power minus 2. Then 1 over a square, 1 over b square. No? Then get common denominator, a square, b square. Then here b square minus a square. Then factorize b minus a, b plus a square, b square. Then here surely positive. We know ab positive, but b minus a, here this is negative. Then the result is negative. That means 1 over a square less than 1 over b square. Okay, likewise you can do. Continue. Do with me. Third one, a to the power minus 3, b to the power minus 3. So we write here a cube, 1 over b cube, get common denominator, b cube minus a cube, b cube, factorize numerator, b minus a, the difference of two cubes, b square, ab plus a squared, a cube, b cube. Here positive, b minus a, this part negative. Then full relation is negative, no? So that idea, 1 over a cube less than 1 over b cube. Continue. Okay, then same time let's do the other one. You think about a to the power minus n minus b to the power minus n, 1 over a to the power n, 1 over b to the power n, get common denominator, a to the power n, b to the power n, b to the power n minus a to the power n, factorize here, a minus b minus a, no? b minus a, start with b to the power n minus 1, b to the power n minus 2 times a, b to the power n minus 3 times a square, it goes on, a to the power n minus 1, a to the power n, b to the power n. You identify the pattern here. This is positive always, and here this part negative, and this is positive. Then full result is negative. So this idea 1 over a to the power n less than 1 over b to the power n. Likewise you can prove. Okay, with star mark write down. For an inequality, the powers can raise when both left hand and right hand sides are positive, when only left hand and right hand sides are positive, when only left hand and right hand sides are positive. For positive positive exponents, sign remains as it is. Signs remains as it is. But for negative exponents, sign get reversed. Okay. Now that is very rare case. Very rare case. Okay, we have another theorem. Let's see. You consider here A, B, C, D real numbers, A greater than B and C greater than D. A greater than B and C greater than D. So here we have two inequalities. Same sense, no? Same sign. Then first make important thing, A plus C greater than B plus D. So that is important thing. So that means we can add same type inequalities. But especially remember, inequality subtraction is not defined. Okay, inequality subtraction undefined. Okay, but only addition defined, that only for same sense. Then opposite sense, impossible. Same sense inequalities we can add it. Then here the proof, A greater than B, the idea is A minus B positive. C greater than D, the idea is C minus D positive. Now add them. 1 plus 2, A minus B plus C minus D, positive addition will be positive. Then say A plus C, B plus D. Here positive, no? I have couple these two and couple these two. Then A plus C minus B plus D positive mean A plus C greater than B plus D. Okay. So that means we can add same type inequalities together, but inequality subtraction impossible. Okay. Do that. Okay, with star mark write down somewhere here. Same sense inequalities can be added together. Same sense inequalities can be added together. Same sense inequalities can be added together. But inequality subtraction is undefined. Inequality subtraction is undefined. Okay. Now here those are major cases. Okay. Those theorems comes with the previous definition. Positive plus positive positive, negative plus negative negative, positive times positive positive, negative times negative positive, positive times negative negative. With that definition we write it, no? Then positive plus negative we can't say, no? With the value we can say, but by considering only sign we can't say the things, no? Okay. Now another one important thing, converse, you consider alpha, beta, real numbers. So first case, if alpha times beta positive, before that alpha times beta negative, okay, A, B real numbers, then what can we say about alpha, beta? One is positive, the other one is negative, no? Then product negative mean alpha and beta opposites in signs, no? Then we can say alpha and beta are opposite in signs. We can't say what is positive value, no? But we can say they are opposite in signs. If alpha beta greater than 0, so the idea, alpha and beta same in sign, no? Both positive or both negative possible, no? Alpha and beta are same in signs. Okay. Third, if alpha beta greater than 0 and alpha plus beta greater than 0. Now you go from here, alpha beta positive mean both positive or both negative, no? If they are negative, we can't say this one correct, no? So definitely you can say alpha beta both positive now. Then by this condition say alpha and beta are positive, are both positive. Fourth one, if alpha beta greater than 0 and alpha plus beta less than 0. See, alpha beta positive mean both positive or both negative, no? But when you go here, if they positive, we can't get negative value. Then both positive impossible. Then both negative will be there. Then alpha and beta are both negative, no? That's how we say it. Okay. That's how we extract sign by this inequality. Okay, just note that one. Okay, those are fundamentals of inequalities. So now we need to think about inequations. Inequations. Okay, now write. There are different inequalities. There are different inequalities to be evaluated. There are different inequalities to be evaluated. There are different inequalities to be evaluated. Usually, for an inequality, there can be infinite solutions. There can be infinite solutions. There can be infinite solution. Therefore, the result set will be represented by set notations. Okay. Now you see this. Here A, here real number line. We can represent this one algebraically. X element of minimum value A, higher value infinity. Here open. Same thing we can denote this way. Here A, here this is included one. Then here we can represent X element A closed. Then use curly bracket here. And infinity always open. Okay. Then see A less than. Then X higher value A, lower value minus infinity. Here open. Here A, when you close this, here this shade mean included. Minus infinity A, this is closed. Here A, B, then both open. Then you can represent A, B, lower boundary A, upper boundary B. A, B, these are some set notations. Then both open. A, B, closed. Here A, B, here one side open. Then X, A closed, B open. No? Likewise, we can represent. Here set notations. Here the way of representing those type of regions. Just note them. Okay, now further you write down. Inequalities can be classified. Inequalities can be classified. Inequalities can be classified with the given function, with the given function, with the given function, put comma, comma. First one, polynomial inequalities. First one, polynomial inequalities. Second one, rational inequalities. Rational inequalities. Third one, modulus inequalities. Third one, modulus inequalities. Okay. Now let's analyze one by one. Okay. Now there can be different other types, but frequently we discuss about polynomial, rational, and modulus. Okay, you know polynomial type linear inequality evaluation techniques. Okay, now subtopic polynomial inequalities. Subtopic polynomial inequalities. Polynomial inequalities. Polynomial inequalities. Okay, under that first one, linear inequalities. Linear inequalities. Linear inequalities. Linear inequalities. Okay. Okay. Now you know linear type inequalities. Let's do with me. Let's do with me. Here examples. 2x minus 1 less than 1 minus 3x. So you can take previous theorems directly and you subject x. This is linear type. The linear mean x to the power 1 relation, maximum x to the power 1 relation. Na? Okay. Now you add both sides 3x. Then we can cancel these two. Here 5x minus 1, 1. Now add 1 both sides. Without changing, we can do this. Now divide by 5. It is positive value. No, without changing, we can do that. X less than 2 divided by 5. That's how we evaluate. Na? But here, you better to represent x element of here maximum value 2 over 5. Then minimum value minus infinity. 2 divided by 5. You better write as a set. Okay. Here there's another representation. X element of real set x such that x less than 2 divided by 5. Likewise, we can represent within curly bracket. Same thing we can represent this way. So anyway, by using theorems, we have to subject x. No need many steps. You can do at once. But I have done this. Here, first theorem. Here another theorem. Same. Then another theorem. No. Okay. Do that example. Okay. Now further you do with me. X plus 1 over 2 greater than or equal 3x minus 1 over 5. Then here positive we can cross multiply. 5x plus 5, 6x minus 2. Then take x side the other side, then x 7. Here it is. Then x element of real set x such that x less than or equal 7. Likewise we can do. You just do with me. Third one, x minus 1 over minus 2 less than x plus 5 over 3. We can multiply by 3 here. Without changing the sign because it is positive. But when you multiply by minus 2, you have to change the sign. No? 3 into x minus 1, reverse sign, x plus 5. Then here 3x, 2x, 5x, minus 3, minus 10, minus 7. No? Then x minus 7 divided by 5. So that is very important. When you multiply by negative value, you have to reverse the sign. Here this sign we have to reverse. Okay, don't miss it. Then finally, we write x element of real set x such that x greater than minus 7 divided by 5. That is really important. When you multiply by negative value, you have to reverse the sign. Okay, don't miss it. You have to subject only x term. Okay, fourth one. So this is somewhat special. 2x plus 1 greater than 2x plus 5. 2x minus 5. See this? Here 2x plus 2 greater than 2x minus 5. You can cancel 2x now. Then 2 greater than minus 5. This is completely true relation, no? Completely true relation. Then this inequality completely true for any real value of x. That is true for any real value of x. Then final answer is any real value is the answer. Then any real value is possible. Very rare case, okay? Then if you see 2 into x plus 1 less than 2x minus 5, same question but here's only sign opposite. Then 2x plus 1, 2x minus 5, 2x plus 2, no? Then 2 less than minus 5. We know this is completely wrong, no? This is completely wrong. 2 less than minus 5, completely wrong. That means we don't have any x value, no? We don't have any x value for get this. This is completely wrong. So this is contradiction sign. Contradiction sign means cannot happen. Then the solution set here, x element of no real value for this. We don't have any real value, no? That's how we do. Okay, these are special cases. Okay, do them. I have given a worksheet, take it. Take that worksheet. First question set, you can do now. Okay, do it soon. That is linear inequality type. Do it now. Do it soon. First question set. Check your answers. Check your answers. 2x plus 4 greater than 3x plus 1. Here x less than 3. Final answer you have to write within curly bracket or that set notations. Huh? So I'm writing here just only answer. X plus 3, 2x minus 1, 4, x plus 1, 2x minus 3, 4, 3x plus 3, x plus 2, here 2x minus 1 divided by 2. 2x plus 3, 3x minus 2, x 5, x plus 6, 9x minus 32, 8x, here 8x, 38, divide by 8. X plus 5 over 2 minus x plus 4 over 3. 3x plus 15, 2x plus 8, 5x minus 7. Minus 7 divided by 5. X plus 1 over minus 3 minus x plus 1 over 2. Cross multiply. 2x plus 2, reverse sign, 3x minus 3. 5. Then x plus 1 over 4 minus 2x minus 3 over 6. And here 2, 3 cross multiply, 3x plus 3 minus 4x minus 6. Check your answers. Okay, then here these are linear type inequalities, no? Linear type inequalities. Let's do one only. Double inequality type. Write down linear double inequalities. Linear double inequalities. Linear double inequalities. Okay, check this. I'll do examples. Here 2x minus 1 in between minus 1 to 2. 2x minus 3 in between minus 1 to 2. Here this is double inequality type. So we have one inequality, another inequality, that's combined one. No? So here case 1, the specialty is x term only in middle term. Other terms are constant term. Only x term in the middle term. Now you try to subject it. Okay, now add 3 minus 3 plus 3, 2x minus 3 plus 3, 2 plus 3. So when we add any constant, sign won't change, no? Simplify, 0, minus 1 plus 3, 2, 2x, 5. Now divide by 2. 5 over 2. Now 1, x, 5 divided by 2. Here the solution. Okay, we can subject it. So final answer, you better write x element of real set or otherwise x minimum less 1, higher value 5 over 2. Better to write this way. See another one. Minus 2, 1 minus 3x over 2, 1. Here again double unequal type. We need to subject x, no? Then multiply by 2. Minus 4, 1 minus 3x, 2. When we multiply by positive value, sign won't change, no? Okay, then we have to remove this one. Subtract 1. Now divide by minus 3. Then we know when we divide by negative value, we have to reverse the sign. No? We have to reverse the sign. That is very important. Now here 5 divided by 3, x minus 1/3. Here the solution set. Okay. Then very simple thing, you have to subject it x. I'll do one another example. Check this one as well. Third one, 1 plus 2x divided by minus 3 in between 1 and 2. Then multiply by minus 3. We have to reverse the sign. Now subtract 1. Divide by 2. That's how we do, no? So very simple thing. Okay, write those examples. That is case 1. Okay, you try these questions. Try these questions. Check your answers. Here subtract 1. Divide by -4. Reverse the sign. Now multiply by 2. Add 4. Divide by 3. Multiply by 5. Subtract 1. Divide by -4. Multiply by 2. Subtract 4. Divide by -3. Multiply by -3. Reverse sign. Subtract 1. Divide by 2. Okay. That is one type, okay? One type. Then the specialty is at the middle term has only x term, no? Middle term has only x. But there can be other sides x terms. Then let's see how to do them. Consider 5 minus 5, 3x minus 4, 6. Here check this method. So double inequality, we say and 5 less than 3x minus 4 and 3x minus 4 less than 6. Then here 9, 3x, 3. And mean intersection. Then 3x, 10, 10 divided by 3. Likewise, you can separate them. We have two inequalities now. With AND operation, you separate it. Now, x value greater than 3. Here, x value less than 10 divided by 3. 10 divided by 3 is somewhere here. Then finally, common region in between 3 to 10 divided by 3. No? Likewise, we can do another technique. Okay, you can split inequality. We have two inequality and double inequality mean we have two inequality. Here with the AND operation, you have to do that. AND mean intersection. Then final answer, you have to intercept them. Here one, here another one, get common region. That is our solution. Okay, do that type again. That technique always applicable. For any double inequality, you can do same. You split and evaluate one by one and get common region. Now here see special case 3 1 minus 2x minus 1. Okay. Now this is somewhat special because initially we know double inequality like this, we can remove this inequality, then this must be satisfied, no? A less than C, that must be satisfied. Then if you remove this one, now 3 less than minus 1, no? It is completely wrong expression. Then this inequality not possible, and contradiction, no real value for this. Okay, you see both 3 and about minus 1. Then 4, 2x minus 1, 3. Cross this one here, 4 less than 3, it is completely wrong. No? Then no real value. We can't evaluate. So if you evaluate here this one and here this one, you get no intercepting region. You don't get any intercepting region. Okay. Now those are special questions. Write them. Okay. Now see double inequality second type, case 2. Case 2, one plus x, 2x minus 1, 4. Now we have double inequality. Previous case we had x term only, middle term. No? We have only middle term as x. Other we have constant. But here we have constant here this side and here constant. Now you split them. You split here 1 plus x less than 2x minus 1 and 2x minus 1 less than 4. Now we just evaluate this. X 2. Here 2x 5. 5 over 2. Now find common region. Then value greater than 2. Then value less than 5 over 2. Then common region is this. That's how we get. Okay. Then very simple. Previous technique. You have to split them. Then evaluate individually. No? Individually evaluate and get common region finally. Okay. Do that example. Okay, you try. Try them. Okay, check your answers. Two x minus 1 less than 3x plus 4. Deception 3x plus 4 less than x. 2x minus 4 minus 2 x minus 5. Here minus 2. Then common region minus 5 to minus 2. Second one 1 plus 3x, 4 minus x, intersection 4 minus x, 2x plus 3. 4x, 3 divided by 4, 3x, 1, 1/3. Here 3/4, value less than 3/4, value greater than 1/3, 1/3 somewhere here, na? Then common region 1/3 to 3/4, na? X in between, three-fourth. So within curly bracket, write everything like a set. Huh? Here 1 minus 4x, 3x plus 1, 3x plus 1 less than 1, 7x 0, x 0, x less than 0, x greater than 0. Here x greater than 0, here x less than 0. We don't have any common region, then no real solution for this. We don't have any real solution. Okay. Then 1 minus x less than 2x plus 3 and 2x plus 3 less than x plus 3, 3x minus 2 minus 2/3, x 0, x value less than 0, x value greater than minus 2/3. Minus 2/3 to 0. Okay. Complete. Okay, now everything under linear inequalities now done. Na? Linear inequality fast fully completed. Now we need to move further polynomial type, quadratic one, cubic one, further any polynomial types we have to do. Then next subtopic, quadratic inequalities. Quadratic inequalities. Quadratic inequalities. Under polynomial, first one linear, now this one quadratic inequalities 2. Just write there. When evaluating a quadratic inequality, when evaluating a quadratic inequality, take all terms into one side, where the leading term is positive, where the leading term is positive, where the leading term is positive. When evaluating a quadratic inequality, take all terms into one side where the leading term is positive. Then factorize it. Thereafter, inequality evaluation can be done. Okay, let's see how to get it. Now see this one very clearly. Before that, you identify, if you see x square term, we can say here x can be any real value. Then squaring, we can convert that into positive. No? Then here this result will be positive or 0. No? Positive or 0. Perfect square means positive or 0. Then expression like x minus 1 square, that also positive or 0. No? X plus 1 square, positive or 0. 2x minus 1 squared, that also positive or 0. No? All are positive or 0. Then you see x square plus 1, here positive or 0 and added positive value. Then surely this one positive. No? Positive only. But here positive or 0, all are positive or 0, but here this one positive or 0 and we have added a constant positive value. That is positive. Then x squared plus 4, positive. X minus 1 square plus 1, positive. X plus 1 squared plus 4, positive. No? Then surely they are positive. Then x square minus 1, we can't sign here. No? X square positive or 0, but when we subtract, that can be positive or that can be negative. Then we can't say sign here. Can't say sign. But here we can directly say. Then x minus 1 square minus 4, we can't say sign. X plus 2 squared minus 5. Again we can't say sign, no? Because of this minus sign, we can't say sign. But for plus, definitely we can say they are positive, no? Definitely we can say they are positive. And these are very important relations. And other than that, we have another special relations. You remember here, x squared plus x plus 1 relation. Here x can be positive or negative. x square plus 1 surely positive. But with this x, we can't say sign exactly now, no? Such case, we better to get complete square. Here it is, complete square method. Then finally, 1 minus 1/4, 3/4. Here, positive plus value, then surely positive, no? Positive. Then for minus, that also minus. Therefore, you remember x squared plus x plus 1 surely positive. X squared minus x plus 1 positive. These relations are very important. Then x squared plus 1 positive. No? These are important relations. Okay, better to note them. This is very important relation. Directly remember those relations. Okay, now see quadratic inequality. Now let's see how to evaluate them. Okay, now I told you two important steps. One step, we need to get all terms into one side, no? We need to get all terms into one side, and the leading term better to get as positive. Okay, we better to get that positive. That is not must, but we better to get leading term positive. And second step, we have to factorize it. If we don't have any proper factors, we need to get complete square. Okay, that is two important steps. Okay, now let's see later how to evaluate them. You consider x minus 1 times x minus 2 greater than 0. Here, quadratic type inequality. First two step has done there. Here. All terms one side, factorize. Here leading term, x square leading term, no? That is leading term, positive. Then, let's see how to evaluate it. Here real number line. Here there are two zeros here. For this factor we have 0, 1. For this factor we have 0, 2. Okay. Then here right hand upper corner, you start sketching a graph like this. Here you change the sign and change the sign. And here upper part we say positive, lower part we say negative. Upper part we say positive, lower part we say negative. Now greater than 0 mean positive. Greater than 0 mean positive region. Here and here the positive regions. Then shaded region are the solution. X less than 1 union x greater than 2. Here the solution. Then very simple technique. Then for x greater than 2, this factor positive, product positive. That's why we select this. X less than 1, here this factor negative, product positive. That's why we take that. 1 to 2 region, here negative, here positive, then product negative, but we need here positive selection. Now, say another one. 2x minus 1, x plus 2, less than 0 case. Real number line, here 0 value minus 2, here 0 value half. Then right hand upper corner, you change, you sketch this way. You always sketch right hand upper corner. Leading term positive, no? Then here right hand corner value will be positive values. Then here positive, negative. Then negative region is this. Then final answer x in between minus 2 to half, no? Minus 2 to half. Okay, do these examples. Okay, let's do another 2-3 examples. Do with me. Do with me. X plus 5, 2x minus 3 greater than 0. Here 0 value minus 5, 0 value 3 over 2. Positive, positive, negative. In positive region, here and here. X less than minus 5 union x greater than 3 over 2. 2x plus 3, x minus 5 less than or equal 0. We have equal here. Anyway, you do same method. Here 0 value 5, here 0 value minus 3 over 2. Positive, positive, negative. Because of this equality, you shade this part. Shade the negative region is this. Minus 3 over 2 to 5. Likewise, you can do. Do with me. 2x minus 1, 2x plus 5 greater than or equal 0. Here 0 value half. Here 0 value 5 minus 5 over 2. And positive region, need to select. Likewise, you can do, no? Then at the beginning, you have to convert to factor format, all terms one side, leading term positive, and factorize. So that must be happen there. Otherwise, we can't say. Otherwise, we can evaluate. Complete them. Okay, now you take your worksheet. Second question set that belongs to quadratic inequality part. Second question set. So factors are not given there. You think and do. Take all terms into one side, where the leading term positive, then try to factorize it. After that, you evaluate by same technique. Continue now. Take your time, no hurry, but do alone. X square minus 4x plus 2 less than minus 1. X square minus 4x plus 3 less than 0. Factorize x, x3, 1, minus, minus less than 0. 1, 3. Negative, positive, positive, Here the region. X square minus 3x plus 2 greater than or equal 0. X 2 1 minus 1 2. For equality, shade this. Positive, negative. Here positive region. X less than or equal 1 union x greater than or equal 2. 3. X square minus 9 less than 0. X minus 3 x plus 3. Then minus 3 plus 3 real number line. Negative region. Here x in between minus 3 to plus 3. 4x squared plus 1 less than or equal 4x. 4x squared minus 4x plus 1 less than or equal 0. Here 2x minus 1 square. Here somewhat special. 2x square, 2x minus 1 square, surely positive, no? Surely positive, no negative value. Then inequality won't there. But equality there. Equal 0 can happen for x equal half only. No any other solutions. We have only half. Then 2x minus 1 square less than part, impossible. 2x minus 1 square equal 0 part possible. Then only for equal we have solution half. No any other solutions, no? 5. 3 minus 2x square greater than 5x. Take all terms into right side. 2x squared plus 5x minus 3 less than 0. Factorize. 2x x3 1 plus minus less than 0. Minus 3 1 over 2. Negative, positive. X in between minus 3 to half. Continue now. Take time. Same technique we can apply for other polynomial types. Same technique we can apply, yeah? Then especially we have discussed polynomial inequalities, rational inequalities and modulus inequalities. Modulus inequality will be for your A-level examination, but others appear with when we are doing some questions, there can be inequality types while we are doing questions. Okay, then that's enough for inequality part. That's enough for inequality part for today.